Howdy, this is the Homework 6 assignment for Dr. Kate Davis's EASN 340 class at Texas A&M University, Fall 2022. Our topic is distribution systems. Our team members are Amara, Nzedibe, Benjamin Mendoza, William Johnson, Kade Mcciggan, and Isabella Castro.
What are distribution systems and why are they useful? Higher voltage is more effective and less expensive for transmission, but lower voltage is safer for homes and businesses. Because of this, we need a system to convert the high voltage used in transmission to the lower voltage needed in homes and businesses. Distribution systems are responsible for converting and distributing this power. A distribution system consists of all of the facilities and equipment connecting a transmission system to the customer's equipment. This can consist of many devices that help safely deliver electricity to where it is needed.
Parts of a distribution system. There are 5 main parts to an electrical distribution. The journey begins at the distribution substations, which receive power from the transmission system that is stepped down by a transformer and transfers it to the distribution system through feeders. Primary distribution voltage is usually 11 kilovolts, but can range between 2.4 to 33 kilovolts depending on the region or the customer. Next in line are primary feeders, which are conductors that distribute power from substations to local load areas. They are strung along a crossbar at the top of utility poles. Before power reaches the load areas, however, it must be once again stepped down to a proper voltage for residential use. Distribution transformers are used to accomplish this. The voltage varies depending on the customer and is typically 120 to 240 volts single phase for residential customers and 480 to 277 or 208 to 120 volts for commercial usage.
After the voltage is transformed, power goes to the distributors, conductors that are placed at the low voltage secondary winding of the distribution transformers and carry power to the consumers. For residential areas, there are 3-wire single-phase circuits that extend along streets past the customer's premises. Finally, services or service mains are small cables that connect the distributors directly to the customer. These power lines can be above ground but are increasingly moving underground. Additionally, switches are installed throughout the distribution system in order to redirect or cut power in order to manage power loads and allow safe repairs.
Since the power demand in residential buildings is much lower than industrial and commercial use, the majority of residents utilize single-phase 120 by 240 volt services. 2 hot lines are provided, one neutral and one ground, that are referred to a 3-wire system. These provide the 2 120 and 240 voltages in house outlets. The majority of house appliances use 120 volts. However, certain larger appliances, such as washing machines, require the 240 volt circuit. The primary distribution system is part of the AC distribution system, which operates at voltages slightly higher than general utilization. The voltage used for primary distribution depends upon the amount of power to be transferred and distance of substations required to be fed. The commonly used primary distribution voltages are 11 kilovolts, 6.6 kilovolts, and 3.3 kilovolts. The primary distribution is done by 3-phase, 3-wire systems because of economic considerations.
There are 3 main ways a power distribution system can be set up. They are the radial system, the ring or loop system, and the interconnected or network system. The radial system consists of only one source for a group of customers. It is the cheapest system to build and is often used in sparsely populated areas. However, any power failure or short circuits would interrupt power in the entire line, which must be fixed before power can be restored. The ring system, unlike the radial system, consists of 2 sources. Here, power loops through the service area and returns back to the original point. This system operates by the help of switches that are placed in strategic positions throughout the system. This helps in cases where one source becomes faulty. If one source fails, switches are thrown and power can be fed to customers using the other source. The interconnected system is made up of interlocking loop systems. Here, a given customer can be fed from more than 2 sources. This system ensures reliability if there is a failure in transmission. It is also the most expensive system and for this reason, it is mostly used in congested or high load density areas.